This is section 4.4, solving multiplication and division equations. So the first thing we're going to talk about here is the division property of equality, which is on page 160. So that says if you divide each side of an equation by the same non-zero number, then the two sides remain equal. So it's really similar to the addition and subtraction properties that we've had before, where if you do the same thing to both sides of the equation, it's still going to stay equal. So we'll write this in. So if you divide each side of an equation by the same non-zero, and they say non-zero because the big math rule is you're not allowed to divide by zero, so you can't divide by zero, so that's why they say that. So the same non-zero number, number in there, same non-zero number, the two sides remain equal. So if you divide by a number on one side, divide by the same number on the other side, both of those sides of the equation are still equal to each other. So let's look at some examples here then. So example 1, we're supposed to solve these out for their variable. So again, we're always doing the opposite. So here, to get rid of multiplying by 5, we're going to divide both sides by 5. So we're going to divide by 5 there, divide by 5 there, and if you want to, you can draw that line down the middle through the equal sign for both sides of that equation. So to get rid of multiplying by 5, we divide by 5 on each side. So then we'll have b is equal to, and then 30 divided by 5 is 6. And we know that we can always take and plug back in, like if I did 5 and then instead of the b I plugged a 6 in there, what we could check is 5 times 6, 30. Well, it is, so 30 equals 30, so that checks out. So whatever number you get for your answer, you should always be able to plug back in and both sides still remain equal to each other. Alright, next one here, b, we've got negative 24 is equal to 3g. So here, they flipped it where the variable's on the other side here, but that doesn't really matter. We're still going to do the same thing. So to get rid of multiplying by 3, we're going to divide by 3 on each side. So the 3's will go away there because 3 divided by 3 is 1, or 1g. And then we do 24 divided by 3, which would be 8, and then a negative divided by a positive is a negative, so negative 8 is what g is equal to. Alright, same thing with c. So even though they've got a decimal in there, it's still the same process. So to get rid of multiplying by a negative 5.5, we're going to divide both sides by a negative 5.5. And if you want to, you can draw that line in between the equals, kind of keep those two halves separate from each other. So if we take both sides and divide it by negative 5.5, those are going to go away, and we're just going to be left with z, because negative 5.5 divided by negative 5.5 just comes out to be 1, or 1z. So we got z there, and then if I take on my calculator negative 22 divided by negative 5.5, it should come out to be an even 4. That would be your answer there. And again, you could plug those back in and see if you're correct. Alright, so on page 161, look at A through C, and then I'll write those answers in. So for A, you should get t is equal to 7. For B, you should get d is equal to negative 3.2. And C, you should get m is equal to 70. So hopefully you got those. Alright, next page here. So we'll start with the story problem. So it says Brian received a $25 gift card from his grandparents for his birthday. How many $2.35 packs of baseball cards can he buy with the gift card? Okay, so there's a couple different ways you could go about this. Some people might be thinking, okay, well, if I've got $25 and I'm going to split that up evenly, I could just take 25 and divide it by $2.35, which is totally true. I'm going to set it up like an equation just because that's what we're working on. But if it didn't say anything about setting up an equation, you could definitely just take 25 and divide it by $2.35 and get however many packs of cards you can get. Because we are working on equations, I'm going to show you how to set it up as an equation. So what I would think here is, okay, total in the end, I've got a $25 gift card. So I'm going to put equals 25 because that's my total. Okay, now I've got to figure out what things are going to get me to that total. So I'm thinking, okay, I know each pack of cards is $2.35. If I take however many packs of cards I get, like say I get 2 packs of cards, if I take that 2 times my price there, that would give me what it costs for 2 of them, right? But since I don't know technically how many I'm getting yet, what I can do is I can take the 2.35 and multiply it by a variable, the variable representing the packs of cards that I don't know yet, and that's what I'm trying to find. Okay, so then what I could do here is to get rid of multiplying by 2.35, I can divide by 2.35 on each side, which is the same as what you might have thought in the first place, just divide the 2 to figure out how many packs. So when we do this here, I'll grab my calculator to show you. When I do this here, when I take 25 and divide it by $2.35, it actually comes out to be kind of a crazy number. So it would be, really this should be approximately equal to 10.638, and it just keeps going. So if you think about it, realistically, we couldn't get quite to 11. Like if you were rounding, you would round this up to 11. But if we've only got $2.35, we can't round that up to 11 and get 11 packs because then we wouldn't have enough money. So really here we can only get 10 packs. So even though it doesn't come out to be an even 10, our answer's got to be 10 packs of cards because we can't have a 0.638 whatever of a pack of baseball cards. We can only have even numbers of packs, and we have to round it down to 10 packs because we don't have enough money to round up to 11. So we'll have some change left over out of our $25, but we can't buy another full pack with that change that's left. Okay, next thing here is multiplication property of equality. So again, kind of a definition or a theorem. So this is on page 161, and it's really similar to the add subtract one and the divide one we just wrote. So it says if you multiply each side of an equation by the same number, the 2 sides remain equal. So the same exact thing as the division one, they just throw multiplication in there instead. So if you multiply each side of an equation by the same number, the 2 sides remain equal, which is exactly the same as what we had before, just now with multiply. Okay, so again, when we're solving equations, for example 3 here, we always want to do the opposite. So if it's W over 7 means divide. So to get rid of dividing by 7, we need to do the opposite of that, which would be multiply by 7. So what I usually do for multiply is I just put big parentheses around the whole thing because we know parentheses mean multiply. So to get rid of dividing by 7, I'm going to multiply by 7 on each side. Okay, so when I do this here, if I take 7 times this W over 7, it's kind of like it's like a fraction like that. And then since the 7s are diagonal from each other, we can reduce those one down and they'll cancel out to 1. So really it's just 1W there, or just W. And then we would take 6 times 7 and get 42. And then again, if we take and plug back in like we did on the previous ones, if I put the 42 in for the W, 42 over 7 is equal to 6. Well, if I take 42 and divide it by 7, I do get 6, so that checks out. Okay, the fraction ones, people usually have a hard time with these. What I like to do, so instead of, so we got, the fraction here, we got -9 is equal to 1/2 m. People always get confused with the fractions, but it's really not too bad. What we're going to do, instead of having that fraction there representing our division, we're going to multiply by the reciprocal. Okay, so the reciprocal of 1/2, reciprocal, we remember we flip it over, so the reciprocal of 1/2 is 2/1. So what we're going to do is we're going to multiply both sides of the equation by 2/1. Because then what happens when we multiply by the reciprocal, if we've got 1/2 times 2/1, the 2's are diagonal, so they can reduce down to 1 and 1, and then you got 1 and 1 there. So really, when we solve this out, when you multiply 1/2 times the 2, or the 2/1, it just comes out to be 1, or just m. And then over on the other side, when we take 2 times -9, that would come out to be -18. And if you think about it, if I took half of -18, that would come out to be -9. Okay, so anytime you've got that multiplied by a fraction out front, instead of dividing by that fraction, what you can do is you can multiply by the reciprocal, or multiply by the flipped over version. Okay, we'll do another one of those. So see here, same thing, we've got a fraction here, so I want to multiply by the flipped over version. Okay, because I really, since it's multiply, you would want to divide by that fraction, but we know dividing by a fraction is the same as multiplying by the reciprocal or the flipped version. So I'm going to take both sides of my equation here, and I'm going to multiply them by -5/2. So I'm just taking that fraction 2/5 and flipping it over to -5/2, keeping that negative sign with it. Because then what happens here when I multiply these two fractions, the 2's cancel out to 1's, 5 cancels out to 1's, and then a negative times a negative is a positive, so positive 1x, or just an x there, is equal to, and then here, to make the -8 into a fraction, I'm going to put it over 1. Then I'm going to, again, look to see if I can reduce. So if I look here, I got -8 and the 2. Well, I can pull a 2 out of both of those. So that would switch to -4. The 2, if I pull a 2 out, that would switch to 1. Then I got 1 and 5. I can't really pull anything out of either of those. So now I do top times top, bottom times bottom. So top times top would be -4 times -5, which would be 20. And then bottoms would be 1 times 1, which would be 1, and then 20/1 is just the same thing as 20. And if I plug that back in there for the x, it should come out to be -8. Okay, so let's try some here. So on page 162, try out D through F, and then I'll get you your answers here. So D, they got T is equal to 32. E, they got A is equal to 30. And F, they got X is equal to -48. So hopefully you got those. Just always remember, if you're multiplying by a fraction, to get rid of it, you multiply by the reciprocal. Okay, that's probably the hardest part of this section. Alright, so we got one more story problem left. So the manager of a theater estimates that 5/7 of people who attend a matinee are children. How many people attended if 250 children's tickets were sold? Okay, so again, I'm going to focus on the total first. So the total in the end here of children that are at this matinee is 250. So I'm going to put equals 250 off to the side. And then I want to set up my other side, what numbers are going to get me to that 250. So if I'm thinking 5/7 of people, basically what I'm going to do is I'm going to multiply my total number of people times the 5/7, and that'll give me how many people is 5/7. So if I take 5/7 times however many people are there, which I don't actually know how many people are there, so that's where I put my variable, that'll give me my 250 children's tickets that are sold. So if we think about it logically here, this number for X should be bigger than 250 because there should be more people that attend this theater matinee thing than the 250 kids that are there. If we had less than that for our total number of people there, logically that wouldn't really make sense. So whatever we get for X should be bigger than 250. So if we solve this out then, what we would want to do is we would want to get rid of this fraction here. So to get rid of multiplying by a fraction, we're going to multiply by the reciprocal. So I'm going to take both sides times 7 over 5. Because then over here, the 7s will cross out, 5s will cross out, being diagonal from each other, so we'll be left with x is equal to, and then I'm going to probably put the 250 over 1, so it's a fraction. Then I look to see diagonal-wise if I can reduce anything. Well, I've got 250 and 5. Both of those would be multiples of 5. So I can pull a 5 out of 5, which is 1. A 5 out of 250 would be 50. And then I've got 1 and 7, which those can't really reduce at all. So now I just do top times top and bottom times bottom. So I do 50 times 7, which would be 350. And then 1 times 1, which would be 1, or just a total of 350. And this would be our total number of people at this theater, matinee, whatever it is. And it logically, like I said, it makes sense that there's more people there than just the 250 kids that are there. So really there must be 100 adults there and 250 kids. Alright, so that's all for the notes for this section. So your book page assignment is page 163, 12 to 34 even.